Let X denote the proportion of employees at a large firm who will choose to be covered under the firm's medical plan, and let Y denote the proportion who will choose to be covered under both medical and dental plans. Okay, suppose Y is greater than equal to 0, is less than equal to X is less than equal to 1, and X and Y have the joint CDF. Fxy equals y times x squared plus xy minus y squared. Calculate the expected portion of employees who will choose both plans. So the ones who choose both plans, the proportion of those is y. So basically we have to find expected value of y. Now this is the first time we're on problem number 230, and it's the first time that we are actually seeing a joint CDF. So we will go over a few formulas that will be needed in this case. So we have to find E of y, as we said, and the fastest way to find E of y in this case is to find the marginal density of y, and then use the formula that expected value of y is equal to y, the integral of y against the marginal density. Now, we haven't really used this formula before, at least not by saying it. We've been using it implicitly. Mostly in a joint PDF situation, we've been finding expected value by double integrating y against the joint PDF. But actually, it comes out to be the same thing. So we have used it without really saying it before. So now the question is how to get the marginal density of y. We know how to get the marginal density of y if we have the joint PDF, but this time we have the joint CDF. So the formula for finding marginal density of y, the marginal CDF, so that's not the marginal density, but the marginal CDF of y from the joint CDF is Fyy is equal to the CDF where you substitute x maximum for the y, where x maximum is the maximum value of x in the domain. So basically, you look at the domain and see what the highest value of x it can take, and you substitute that value of x in the joint CDF, and that gives you the the marginal CDF of y. And similarly, if you had to find the marginal CDF of x, then you would substitute the maximum value of y. Okay, so that is out of the way. So here the maximum value of x is 1 because this is the domain. X ranges in these values, so minimum is 0 and maximum is 1. So therefore we'll substitute x equals 1 to get the marginal CDF of y. So when I substitute x equals 1 here, I have y 1 plus y minus y square, and that is the marginal CDF of y. And the marginal PDF of y is the derivative of the marginal CDF, as always. The any CDF, any PDF is the derivative of the corresponding CDF. So to take the derivative, I first multiply it out. So this is y plus y squared minus y cubed, and I take the derivative of that. And that's 1 plus 2y minus 3y squared. And now here I need the y bounds. So if we look at the original bounds, y bound, you can see from here that y would range between 0 and 1. And since to get the marginal PDF of y, we've eliminated x. So you can think of just eliminating x from this chain, and we're just left with y between 0 and 1. So As we said, the general formula of the expected value of y is the integral of y against the marginal PDF of y. And here y goes from 0 to 1. And this is the marginal PDF in that range. So y times the PDF, marginal PDF. So before integrating, we'll multiply the y out. So y plus 2y squared minus 3y cubed. And when you integrate, this is y squared over 2 plus 2y cubed over 3 minus 3y 4 over 4. And when you substitute the limits, you end up with 0.42. That is choice C.